Okay, so let's continue with the tutorial. Okay, so example. And the example or the question says the following. Are the following two matrices row equivalent? So we have minus 1, 1, 1, 1, and 2, 1, 1 minus 1. Okay, so those are our two matrices. So how do we prove that? If we recall from the lecture, we say that the proof depends on this theorem. Okay, the theorem says each matrix is row equivalent to a unique reduced echelon form. So basically, to prove whether two matrices are row equivalent or not, we need to get the reduced echelon form of each of the matrices and then compare the reduced echelon forms. Okay, so basically what we are going to do is to perform Gauss-Jordan reduction on each matrix, okay, to get the reduced echelon form, to reduce their reduced echelon form. Okay, so that's step number 1. So let's do it. We have our first matrix is minus 1, 1, 1, 1. So let's do Gauss-Jordan, very easy. We have row 1 plus row 2, okay, minus 1, 1, and 0, 2. Now we need to turn the leading entries into 1, so we have minus row 1 will give us 1 minus 1, and then we have a half, row 2 will give us 0, 1. And then we will use each entry to eliminate the entries, each leading entry to eliminate the entries above them, or above each entry. So here I'm going to do row 2 plus row 1. Okay, so it will leave me with 1, 0, 0, 1. So this is my reduced echelon form of the first matrix. So, okay, so let me this purple there. Now let's do the same thing for the second matrix. 2, 1, 1 minus 1. Okay, so I have a minus a half, row 1 plus row 2 will give us 2, 1, 0. So minus and plus, so minus 3 over 2. Okay, then we have turned the leading entries into 1. I have a half, row 1. Okay, will give us 1 and a half. And then we have minus 2 over 3 times row 2. I have 0 there. Okay, so 1 there. And then use the 1 in the second row to eliminate the half in the first row. Okay, so we have a minus a half, row 2 plus row 1. Okay, so 0, 1 there, 1 and 0. As you can see, the second matrix also reduced to the same echelon form. Okay, so let's say the two matrices reduce to the same echelon, to the same reduced, is very important, reduced, okay, echelon form. Therefore, they are row equivalent. Okay. Recall, when we perform just Gauss method, we get the echelon form of the matrix. But when we perform Gauss-Jordan reduction, we get the reduced echelon form of the matrix. Okay. Therefore, we can conclude that the two matrices are equivalent because they have the same reduced echelon form. Is that okay? So we can stop it here, and we will continue in the next video with the lecture. Thank you.